everyone. It's important that you understand how to find and learn also the sine, cosine and tangent of some important angles, and those are 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees. It really helps if you can learn these, and I'll show you some ways of learning them later. First of all, how to derive them though, and we derive the sine, cosine and tangent of 45 using this, Dr. Frost calls it a half square. It's just an isosceles triangle where the height and the base are both 1 unit. And if you think about it, by Pythagoras' theorem, the hypotenuse here is going to be the square root of 1 squared plus 1 squared, so it's going to be root 2. Okay, so this length here is root 2. So if we want to find the sine of 45 degrees, so 45 degrees is here, the opposite is going to be over here, the adjacent is here, and the hypotenuse is here. So sine 45 is going to be the opposite divided by the hypotenuse. Well, that's 1 over root 2. Cos 45 is the adjacent divided by the hypotenuse, so that's also 1 over root 2. And tan 45 is the opposite over the adjacent, so that's 1 divided by 1. If we simplify those, well, we can rationalize the denominator for sine and cosine of 45. If we multiply the top and the bottom by root 2, the top becomes root 2, the bottom is root 2 times root 2, which is just 2. So these two are both root 2 over 2, and of course 1 over 1 is just 1. Now, to find the sine, cosine and tangent of 30 degrees and 60 degrees, we start with an equilateral triangle, and the lengths of each side of that equilateral triangle, for convenience, we call them 2, and you'll see why. So this length here is 2, and this length over here is also going to be 2. And if we split that equilateral triangle in half, so down the middle here, obviously that's a line of symmetry, and because each angle in an equilateral triangle is 60 degrees, so we've got 60 here and we've got 60 degrees here, and because we've split it down the middle, this angle at the top here must be 30 degrees. Now again, we need to find the height here. In this case by Pythagoras' theorem, so we need to find this length here. We're going to do the square root of 2 squared minus 1 squared. Well, that's the square root of 4 minus 1, which is the square root of 3. So this length here is the square root of 3. Okay, so let's start with 30 degrees. We're going to find sin, cos, tan of 30 degrees. So 30 degrees is up here, which means that the hypotenuse is here, the opposite is the 1, and the adjacent is the root 3. Okay, so if we want to find sine 30, well, that's opposite over hypotenuse, so that's going to be 1 over 2. So sine 30 is a half. Cos 30 is adjacent over hypotenuse, so that's going to be the root 3 over 2. And tan 30 is opposite over adjacent, which is 1 over root 3. And while we're here, let's rationalize the denominator. Remember, we don't like the surds on the bottom. Multiplying the top and the bottom by root 3 gives us root 3 on the top and 3 on the bottom. Okay, for sine 60, what happens if I just do that in red is if the 60 degrees is here, the opposite is the root 3, so this one becomes the opposite, and the adjacent is the 1. Okay, so I'll just change that and I'll do this one in red as well. Okay, so for sine of 60 degrees, we want the opposite over the hypotenuse. Well, that's root 3 over 2. Cos of 60 degrees is the adjacent divided by the hypotenuse. Well, that's 1 over 2. And tan 60 is the opposite divided by the adjacent, which is root 3 over 1. Obviously, that is just root 3. Now, I'd like you to notice something here. Obviously, there's quite a strong pattern. Sine 30 is the same as cos 60. Okay, so let's just write that down. So sine 30 is the same as cos 60, and they are both a half. In the same way, cos 30 is the same as sine 60. So this one is the same as this one. Okay, so let's just write that down. So sine of 60 is the same as cos of 30. And if we think back to the previous page, we also had the fact that sine 45 is the same as cos 45. Remember, they were both root 2 over 2. And it is always the case that if you have the sine of one angle, let's call it theta, that is always going to be the same as the cosine of 90 minus theta. That's very useful Okay, so if you've got something like, let's just over on the left hand side here in purple, in blue, if you've got something like sine of 40 degrees, you know that that is going to be the same as cos of 50 degrees, and so on, as long as the two angles there add up to 90 degrees. Okay, I'm now going to give you quite a cool way of remembering, or trying to figure out quickly, the sine, cosine and tangent of 0, 30, 45, 60 and 90. Okay, what you do is you set yourself up a table which looks like this, with those 5 important angles across the top. So 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees across the top. Okay, and down the side you have sin, cos and tan in the same order that they appear on your calculator button. So that's pretty easy to remember. Okay, right, all you really need to remember here is the first entry, because after that it's quite easy to get stuck in your mind. So what is the sine of 0? Well, down here I have drawn the graphs of y equals sine x, y equals cos x, and the sine one is the one which is in red here. Okay, so this one here, and you can see clearly from the diagram, and you should know this from a previous chapter, that sine 0 is actually 0. So you can remember that pretty easily. What you then do, and you'll see why later, this is very interactive, is you count up from 0 in 1. So basically we go 0, 1, 2, 3, 4. And on the next line down, you do exactly the same in reverse. 4, 3, 2, 1, 0. Okay, now for all of those numbers, the first thing that you do is you square root everything. So square root every single number that you have written so far. Root, 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 root. And you then divide absolutely everything by 2. So that one divided by 2, divide by 2, divide by 2, divide by 2, divide by 2. So all you've got to do is just remember this process. Divide by 2, divide by 2, divide by 2. Now if you simplify each of these, so let's change the colour of my pen so that it's a bit easier to see. Okay, first one, square root of 0 divided by 2, well that's obviously just 0. Square root of 1 divided by 2, well that's just a half. Root 2 over 2, that's correct. Root 3 over 2 is correct. Root 4, well square root of 4 is 2, and 2 divided by 2 is just equal to 1. Okay, so on the next line, these are the same but in reverse. So this is 1, this one's correct, this one's correct, this is just a half, and this one is just 0. Okay, now to find the tan, you just need to remember an important fact, and you'll be doing more of this in this chapter, that the tan of any angle is equal to the sine of the angle divided by the cosine of the angle, and we'll be proving that later in the chapter. So tan is just sine divided by cos. So if we want to find tan for this one, we're going to do 0 divided by 1, well that's just 0. This one we're going to do half divided by root 3 over 2. Now to start off with, you think, oh my god, that's horrible. Half divided by root 3 over 2, well that's just the same as a half multiplied by 2 over root 3. And notice that the 2's cancel, and you end up with 1 over root 3. So to do this division, to do a half divided by root 3, you forget about the 2's, you just do 1 divided by root 3. So this is 1 divided by root 3. Here you're dividing something by itself, so you're going to have just 1. Here, root 3 over 2 divided by 1 over 2. Again, the 2's disappear, and you're left with root 3. And here, 1 divided by 0. Remember, if you divide anything by 0, you get infinity. And you know that from the tan graph, that tangent of 90, here's tan in green. This one here, tan of 90, so here's 90 degrees here, tan 90 is actually infinity. Okay, 1 over 3, this one over here, we can write as root 3 over 3. So that gives you a sort of fairly quick and easy way of remembering that table. Okay, on this next page we're going to learn about something called the unit circle, and it gives us an idea of how we can work with trig ratios, so sine, cosine and tangent, for angles which are not just in the range 0 to 90. Okay, and it helps us to understand these trig ratios for any angle. Okay, so let's consider this triangle down here. Okay, so it's a right angle triangle where the length of the hypotenuse, and that's really important, the length of the hypotenuse is 1. Okay, now if you think about, we have angle theta here, so we have the opposite here, the adjacent here, and the hypotenuse here. Okay, now if you think about it, if we worked out sine theta, well, you know that sine theta is the opposite divided by the hypotenuse. Now, in this case, the opposite divided by the hypotenuse is just going to be the opposite divided by 1. So if I just write opposite divided by 1, well, obviously sine theta then is actually just the opposite. So this length here is actually sine theta. Now, in a similar way, if we look at this length across the bottom here, I'm going to write that cos theta is the adjacent divided by the hypotenuse. But in this case, cos theta, well, because the hypotenuse is 1, cos theta is actually the adjacent. So this length over here is actually cos theta. And that's very, very important. Okay, so let's think about what we call the unit circle. So imagine we've got some axes like this, and this point P is able to rotate anywhere it likes. So this angle theta can get bigger and bigger, or it can go in the opposite direction. P can rotate around in a circle, okay? And the distance from the origin to P is 1 unit. So P, if you like, is this point here, which can rotate in a circle around the origin, okay? If you think about P, okay, and look at this, let's just rub that out and try and understand what I'm trying to say. If you imagine this triangle that I've drawn over here on the left-hand side, so that triangle I've sort of transplanted, if you like, over to here. So here is the triangle, okay, and because we understand that this bit down here is cos theta. So cos theta, if you like, is the x coordinate, and this length here is sine theta. The coordinates of P will always be cos theta, sine theta. Okay, so cos theta across, sine theta up. Okay, now if you think, let's have a think about tan now. Tan is going to be the opposite. So remember, we had the opposite was here, and the adjacent was here. You can see that tan theta is going to be, well, for a start, we can think of it in 2 ways. Tan theta is sine theta divided by cos theta, the opposite. So the opposite divided by the adjacent is going to be sine theta divided by cos theta. But it's also going to be the gradient of this unit line, if you like, the line which is 1 unit long. So the gradient of the line, okay, because that is the vertical divided by the horizontal, the gradient is going to tell you tan theta. Okay, so just to recap the previous page, so remember, as this point P travels around this unit circle, so a circle which has got a radius of 1, the x coordinate that wherever P is cos theta. The y coordinate is the sine of the angle, and the gradient is always tan theta. Okay, so let's have a look at the coordinates of angles, and let's have a look at this original diagram here. You can see for angles between 0 and 90, okay, so that's up in this diagram here, because the coordinates of P are both going to be positive, so it might be something like, well, I don't know, but they're both going to be positive. So for angles between 0 and 90, we can see, so for 0 to 90, we can see that sine theta is going to be positive. We can see that cos theta is going to be positive, and tan theta, remember, is the gradient of the line. That line has a positive gradient, so that will also be positive. Okay, let's have a look now, though, at 90 to 180. Okay, so if I draw the diagram again, the unit circle diagram, we would have an angle which is over here somewhere. Okay, so think about there, P is there. Okay, that length is 1. Okay, sine theta, remember, that is going to be the y coordinate. Well, the y coordinate of this point here is going to be positive. If we look at cos theta, though, okay, that's the x coordinate. The x coordinate, these are negative numbers over here, so this is going to be negative, something like -3, doesn't really matter. Cos theta is going to be negative. We're only interested in the signs. Tan theta, if we think about that one, well, the gradient of this line that I've just drawn is negative. Okay, so between 90 and 180 degrees, okay. Oh, I'll tell you what I forgot to tell you is that going round in this direction, we call this a positive angle. Okay, if we go in the opposite direction, we call that a negative angle. We'll come back to that later. Okay, let's think now about angles which are between 180 degrees. So 180 to 270. Okay, so I'm going to draw my diagram again. So 180, so 0 to 90 would mean P is in this section here. Okay, from 90 to 180, P is in this section here. Between 180 and 270, P is going to be over here somewhere. Okay, so think about what's going to happen to sine theta and cos theta, whether they're going to be positive or negative. Okay, so remember, sine theta is the y coordinate. So if you've got a point which is over here, let's just highlight that a bit more. So if you've got a point here, the y coordinate is actually going to be negative. So sine theta will be negative. Cos theta, well, that's the x coordinate. That is also going to be negative because it's to the left of the y-axis. And tan theta, okay, well, if you look at this line here, it's actually gone back to having a positive gradient. Tan theta is going to be positive. Okay, so in this section over here, and we actually call these sections quadrants, sine and cosine are negative, but tan is positive. Okay. Okay, on this page, what we've got are lots of diagrams showing the different position of P as P moves around that unit circle for different values of theta, so for different angles. So as I said, remember, going in a anti-clockwise direction, because so going in this direction is taken to be a positive angle, and going in the opposite direction, so clockwise, is taken to be a negative angle. Now on this page, all of the angles that we're thinking about are going anti-clockwise, so we're talking about positive angles. Okay, so let's think about what happens when that angle theta is 0. Okay, so in the first diagram here, P, you can see, is just one unit to the right. Okay, so let's think about each one. So sine theta, remember that's the y coordinate, well sine theta is actually going to be 0. Okay, cos theta, that's the x coordinate, that's going to be 1 because you're going 1 unit into the right, and tan theta is going to be 0 because you can see that the gradient of this horizontal line is 0. Okay, as we did on the previous page, for the second one we have got sine theta and cos theta and tan theta are all positive. Okay, so positive, positive, positive. Okay, when theta is 90 degrees, well, sine theta is the y coordinate. We can see that that's 1. Cos theta is the x coordinate. We can see that's 0 because the coordinates of P are actually 0, 1. And if we look at the gradient, tan theta, well, the gradient of a vertical line is actually infinity. And if you start thinking about this, this is agreeing with the graphs that you know. Sine theta is 1. When theta is 90 degrees, sine of 90 is 1, cos of 90 is 0, and tan of 90 is infinity. Okay, between 90 and 180, sine theta, well, we can see that that's the y coordinate. Remember, sine theta is positive. Cos theta, though, the x coordinate, is negative. We saw this on the previous page. And tan theta is the gradient, which is negative. Okay, theta is 180 degrees. Think about the coordinates of P here. Well, the coordinates of P are -1, 0. Okay, so sine theta, remember that's the y coordinate. Sine theta is 0. Cos theta is -1, and tan theta, well, we've got a horizontal line, so tan theta is 0. Okay, which because the gradient is 0. Right, between 180 and 270, and we did this on the previous page. Now you can see sine theta is going to be the negative one. Cos theta is also negative because the coordinates of this point are going to be negative something, both negative. Cos and sine theta are both negative. Tan theta, though, which is the gradient, is going to be positive. Right, when theta is 270, well, P is down here. Coordinates of P are 0, -1. So sine theta now is -1. That's the y coordinate. Cos theta, the x coordinate, is 0. And tan theta, well, again, we have got a vertical line, so the tangent, which is the gradient, is going to be infinity. It's actually negative infinity, but it doesn't really matter in this case. Right, from 270 to 360. Okay, so let's have a think about sine theta. Well, sine theta, remember, is the x coordinate, sorry, the y coordinate. The y coordinate is negative because it's below the x-axis. Cos theta is positive because the x coordinate here is going to be positive. Tan theta, so we're back to the gradient. The gradient is going to be in this direction, so it's got a negative gradient. Okay, let's just consider these because the important ones that I would like us to look at are this one, this one, this one, and this one. Okay, the rest of them we can get from the graph. We know those values from the graphs. But notice between 0 and 90, all of these are positive. Okay, between 90 and 180, it's the sine which is positive and the rest are negative. Between 180 and 270, tan is positive and the others are negative. And between 270 and 360, cos is positive and the rest are negative. And you need to learn this. So all of them, sine positive, tan positive, cos positive. Okay, on the next slide, we're going to look at how we can get that from the graphs as well. Okay, just to reiterate what we did on the previous page, this shows also quite nicely how the various angles are. Okay, now basically, if the curve is above the x-axis, then the sine, cosine, or tangent, whatever it is going to be positive. Now, if we look at between 0 and 90, okay, so that's here. So between 0 and 90, all three curves, so there's the sine curve, there's the cosine curve, there's the tangent curve, all of them are above the x-axis, so they are all positive. Okay, so sine, cosine, and tangent are all positive between 0 and 90. Between 90 and 180, okay, you can see that the sine curve is up here, so it's positive. So sines are positive, whereas the other two are down here, which makes them negative. So sine is positive here. Between 180 and 270, the only one which is positive is this one, which is tan. So tan is positive. And then between 270 and 360, this is the only positive one. So cos is positive between 270 and 360. Okay, so just get your head around those. Okay, after 360 degrees, as you know, all the graphs start to repeat. So this sequence, if you like, of positivity repeats, and it also repeats in a negative direction down here. Probably the most important thing you're going to learn today, though, is this thing called the cast diagram. And the cast diagram gives you a really nice, easy way of remembering which of those three trig ratios, sine, cosine, or tangent, are positive and where they are positive. Okay, so the cast diagram, really simple little diagram. It's basically just draw this. Okay, so the same axes as we had for the unit circle. So remember, for the unit circle, 0 degrees was there. A positive angle is measured in that direction and a negative angle is measured in that direction. And really, this is how we define a negative angle. Negative angle is just measured in a clockwise direction round from 0. So if we put in a positive direction, 90 degrees would be there, 180 degrees would be there, and 270 degrees would be there. Now, basically, those angles aren't just 90 degrees. If we carried on round, this 0 here could also be thought of as 360, because if we go all the way around like this, that's 360 degrees. The 90 is also 450 degrees. If we go in a negative direction, this 270 degrees is actually the same as minus 90, and so on. So this diagram gives us a way of being able to show any angle on a simple diagram rather than having to draw the graphs. Okay, let's just fill in those gaps. Okay, so remember what we said, between 0 and 90, all of them are positive, so sines, cosines, and tangents. Between 90 and 180, sine is positive, but the rest are negative. Between 180 and 270, all tangents are positive, the rest are negative. And here, cosine is positive, and the rest are negative. So all you really need to remember is that is the letter A for this section, the letter S for this section, the letter T for this section, and the letter C for this one. Okay, you can see why it's called the cast diagram. You've got C-A-S-T. I prefer to call it the A-S-T-C diagram, and when I draw it, I put the A there, the S there, the T there, and the C there. You must make sure you get these in the right place. Okay, we're now going to use the cast diagram to work out, without a calculator, the sines, cosines, and tangents of lots of angles which are not between 0 and 90. Okay, and in order to do that, it's a very good idea when you do these questions, which are in exercise 10A and exercise 10B, is to have in front of you, just draw it out, the little table that shows you how to find the sine, cosine, and tangent of 0, 30, 45, 60, and 90. Okay, so let's have a look at how it works. So tan 225, what you do, draw a little cast diagram. Okay, and I'm going to be drawing lots of these. Remember, it goes A, S, T, C, and then think 225 degrees. Well, 0 is here. 225 is a positive angle, so I'm going to go in that direction. If I work my way round, 0 to 90 is there. 90 to 180, 180 is there. 225 is going to be in this section here. Okay, so that this angle here is 225. And what you do now is you work out the angle which is made with the x-axis. Always the angle made with the x-axis. And if it's 180 round to there, 225 take away 180 leaves me 45. Okay, now what that means is that tan 225 is either going to be the same as tan 45, so exactly the same, or it might be the negative version of tan 45. Okay, so what we're actually doing is we write each angle in terms of an acute angle, so in terms of an angle between 90 and 180. Now, to decide whether it's the positive version or the negative version, just look at which section this line is in. So this line is in the T section, which means tangents are positive, so tan 225 is the same as tan 45. Now, we know from this table over here that tan 45 is actually just 1. Okay, so the answer to the first one is just 1. Right, let's have a look at the next one. We have tan 210, so I'm going to draw 210. Okay, so A, S, T, C. Okay, going round to the diagram, it's a positive angle, so 90, 180, so again it's in this section here. So tangents are positive, we already know that, so we know it's going to be the same as tan. But what's the acute angle? Well, what's the angle between the line that I've drawn here and the x-axis? Well, if that's 180, the whole thing is 210. This angle here must be 30, so it's the same as tan of 30 degrees. And tan 30, if we look at the table, tan 30 is going to be root 3 over 3. No need for a calculator. Okay, sine of 150. Let's do that over here. So A, S, T, C. 90 is there, 150 is there. And the angle made here, if this one here is 150, then this angle here is 30. So sine of 150, good. Sines are positive in this section here. Sine 150 is just the same as sine 30, and sine 30 from the table is a half. Right, cos of 300 degrees. Let's find 300. So A, S, T, C. Okay, 90, 180, 270, or 300 is in this quadrant here. So if that's 300 degrees, angle made with the x-axis always, well, that's going to be 60 degrees. So cos 300, we're in the C section where cosines are positive, so cos 300 is just cos 60, and cos 60 from the table is just a half. Okay, so that one's a half. Sine of minus 45. Now, to show a negative angle, I'm going to do it over here. Remember, negative angles are measured in this direction. So I'm going to put 45, so that is 45 degrees. The angle made with the x-axis, that's easy, that's going to be 45 degrees. A, S, T, C. Okay, the sine of minus 45. Now, we know it's going to be something to do with sine 45. But is it going to be positive or negative? Now, in this case, because this angle of minus 45 is in the C section, sines will be negative. Cosines will be positive, sines negative. So it's minus sine 45. And sine 45, we can see from the table, is root 2 over 2. So it's minus root 2 over 2. You can check all these on your calculator, by the way, but there's no need because we know we're right. Cos 750 degrees. Let's just make ourselves a little bit of space over here. Okay, cos 750 degrees, let's just draw a cast diagram again. So 750, positive angle, so A, S, T, and C. So going round, I know that it's 360 all the way round to there. So 360, add 90, 450, add 90, 540, so 630, it's right, 720 all the way around, so I should have realised that. So it's 720 all the way around. We're going as far as 750, so that's here. And if it's 720 to here, okay, then this angle at 750 must be 30 more. So the angle made with the x-axis is 30 degrees. Now, it's in the A section. All of them are positive, so cos 750 is just the same as cos 30. and cos 30 is the same as root 3 over 2. Last one, cos 120. Okay, so A, S, T, C. Cos of 120 degrees, well, there's 90. 120 is in this section here. The angle made with the x-axis, as usual, if that's 120, this here is going to be 60. Okay, it's in the S section where cosines are going to be negative because only sines are positive there. So it's going to be negative, and it's going to be the same as negative cos 60 degrees in terms of the acute angle. Cos 60 is a half, so it's going to be minus a half. Okay, just 5 more to practice with here. Okay, so I'm going to start with my cast diagram as usual. Okay, so draw the cast diagram. So 315 degrees, so ASTC. So 90, 180, 270, 315 is going to be over here. And if that's 315, then this bit here must be 45 degrees. So cos 315 in the C section is going to be positive. So that's going to be the same as cos 45 degrees. And from the table on the previous page, that's going to be root 2 over 2. Okay, next one, sine of 420 degrees. Here we go, draw my cast diagram. ASTC, 420, well, we know it's 360 all the way around. 450, though, would be too far, so 420 is there. So this is 360 all the way around. So this bit is going to be, sorry, it's 420 all the way around. This angle here is going to be 60, the angle made with the x-axis. Okay, so sine 420, because it's in the A section, is just going to be the same as sine 60, and sine 60 is just root 3 over 2 from the table. Tan of minus 120, so remember, I'll do it right over here. Okay, so ASTC, minus 120 means we go in this direction, so that's minus 90. Minus 120 is there. So if this angle here is 120, the one made with the x-axis is going to be 60. Okay, so tan of minus 120 in the T section is just the same as tan 60, and tan 60 from the table is root 3. Tan of minus 45, so similar idea. So you've got ASTC, minus 45 degrees. Well, there's 0 going in a negative direction. Minus 45 degrees is there, so that angle is 45 degrees. Is in the C section, so it's the same as tan 45 because the angle made with the x-axis is 45 degrees, but because it's in the C section, it'll be negative, so minus tan 45 is just going to be minus 1. Okay, and so the last one, sine 135, let's just rub out that one there. Okay, so I can just draw a new one. Where are we? Okay, so here's my cast diagram, ASTC, 135 or 90, 135 is there, so that this angle is 135, which means that this angle here is 45. So sine of 135 is going to be positive because it's in the S section. It's just going to be sine 45, and sine 45 is root 2 over 2.